Hello guys, this is CodeNCode and this is video tutorial for the concept that how we can calculate the total number of ways for reaching from coordinates 1 1 to nm, and we are talking about the grid. So basically, if we look at the problem statement, it is this: we are given a 2D grid of size n cross m and we have to find the total number of unique path from 1 1 cell 1 1 to nm, basically from top left corner to bottom right corner, and we are only allowed to go either down or right. So from this cell you can go either down or right. So for this example test case, starting from here to here, there are 4 ways you can reach, starting from starting point to terminating point, and those 4 ways are this: you can go like this or this or this or this. So these are the 4 possible and unique paths from S to T, basically top left corner to bottom right corner. First thing, if you haven't seen previous 2 or 3 lectures that we have already studied in dynamic programming course part 1, then I highly advise you to go and watch those lectures. I guess those are lecture 11 or 12. I don't actually remember the lecture name, number of the lectures. I'll be putting the link of those lectures in the description of the video. So I'm asking you to watch those lectures first, because there are many similarity between those problems that we have solved and those algorithms that we have studied. Those also work on 2D grid. Those were also quite similar to what we are going to study in this lecture. That is why I'm asking you, if you haven't watched those lectures, just go and watch those lectures first, and then let's continue. So this is the problem, how we are going to count the total number of ways. So, well, the important observation is that since from coordinate xy we can only go down or right, or down means x plus 1 y and right means x y plus 1. So the total number of unique path from x to y would be sum of total number of unique path from x plus 1 y plus x comma y plus 1. Basically, the total number of ways you can reach from this cell to this cell, the total number of ways you can reach from this cell to this cell is total number of ways you can reach final cell from this cell plus total number of ways you can reach final cell from this cell. And why is that so? See, suppose you are at some place and then you want to go home, and this is your home and this is your current position, and then from your current position you can take flights to your home country, and then suppose these are 2 airports in your home country. So you have 2 options: either to take flight and reach this point, this airport, or take flight and reach this airport. Right now you already know that, okay, from airport 1, say this is airport 1 and this is airport 2. So from airport 1 there are 3 ways you can reach your home, right? And from airport 2 there are 7 ways you can reach your home. So in total, how many ways you have to reach home from this position? Well, of course 10, because there is only one way you can reach from this to airport, and then from airport 1 there is 3 ways. So in total, from here you can reach 3 ways you can reach from here to here, right? Now from here to airport 2 there are 7 ways. So one way to reach from your position to airport 2, and then from there are 7 ways to reach your home. So in total you are having 10 ways to reach home. Similarly, if there are x ways to reach from here, let's say p, because x and y we are already using. So if there are p ways to reach from here to home and q ways to reach from here to home, then in total for you to reach home there are p plus q ways, because you can take one step and reach here, and then you have p number of ways. You can take one step and reach here, and then from here you have q number of ways. From here you cannot go anywhere else. So in total, the number of path from this cell to final cell is sum of number of path from this cell plus plus number of path from this cell. So that leads us to a recursion. That means to calculate the total number of unique path from here to final cell, you need to have the total number of unique path from here to end and here to end. That is why before calculating this, we must calculate these two if we are working with iterative approach. And of course, in this lecture, we are going to study iterative as well as recursive approach both. So how we gonna calculate it? It is very easy. What we are going to do, of course, if you start from nm itself, the number of ways to reach nm from nm is equals to 1, right? But what we are going to do, the pre-processing step is that fill all element in the last row and column with 1. So last column and last row have been filled with 1. Why? See, if you pick any cell in the last row or last column, there is only one way you can reach from that cell to the end. Why? See, from here there is only one way you can reach here, and that is by taking this path. There is no other way. Similarly, choose any cell in the last column and there is only single way you can reach end from that cell, and that is by going down. So the last row and the last column will be filled with 1, and this is your pre-processing way, and this is the iterative approach, because here we are not going to use recursion. So the pre-processing step is fill the last row and the last column with 1. Now we are going to build the solution for the rest of cells. Now starting from n-1th row, because the last row we have filled, the nth row we have already filled, now we are left with n-1, n-2 dash 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 till 1. So we will start from n-1th row and we will be start filling from n-1th row to first row. So we'll start from n-1st row, we'll fill row by row. And how we are going to do that? We'll start from rightmost cell which is not filled, which would be m-1th column, and then go till the first column. So I'll be filling this by starting from here and then here and then here. So let me show you. So first we are filling the n-1th row. So how we are going to do that? Of course, we would start from m-1th column. So we'll be filling this column, this cell first. So the total number of ways you can reach from here to your goal or end point or destination or terminating point is equals to sum of the down and the right cell. So sum of down and right is 2. Now we go and fill this cell. This is of course sum of right and down. So now you know why we are going from right to left, not left to right, because when you are going to fill from, let me show you, when you are going to fill from left to right, to fill this cell you must have the total number of ways to reach destination from this cell, but we haven't found that yet. That is why we are starting from right towards left. So for this it would be the sum of right and down, because from here you can either take down or go right. So the sum is 3. For this it would be 4. So of course the n-1th row has been completed. We would go to n-2nd row, right? So this cell would be sum of these two, and this cell would be sum of these two, and similarly this cell would be sum of these two, which is 10. Now the n-2nd row has been completed. Now the first row, sum of these two, now this would be 10 and this would be 20. So starting from 1 1, the total number of ways to reach 4 4 is equals to 20. So starting from this cell you can reach this cell in 20 unique ways. So this is how iterative approach works. So let me show you the code. Oh, this is recursive. No. So we have taken a DP array of size 101 cross 101. These are NNM. So we're reading NNM, initializing the last row, I guess. Nth row, yeah, the last row is being initialized with 1, last column is being initialized with 1. So here we are initializing the last row and the last column. After that, starting from n-1th row, we would be filling row by row, and starting from m-1th column as explained here in the slides. So starting from n-1 towards 1, I minus minus, j starts from, that is column number, start from m-1 till j is greater than or equals to 1, j minus minus, dp of ij is equals to dp of ij, I plus 1j plus dp of I j plus 1. Now this is completed. Finally printing the 2D DP array. REP is actually for loop which runs from 1 to n. Similarly this would run from 1 to m. If I show you for 4 cross 4, as you can see, this is same as this. The last row and column are filled with 1, and then 432, 432, 10 6 3, 10 6 3, 20 10 4, and 20 10 4. So this was iterative approach. Now the recursive approach, for me, writing recursive code recursive code is a bit easier than writing iterative approach. So what we are doing here in recursive approach, we need to have a DP array to memorize the states, to store the results of each state. So what we are going to do, we are going to first reading input, and then the DP array is being initialized with -1. DP is a 2D array of size 101 cross 101. I'm assuming the max size of n cross m can be 100 cross 100, and since I'm working with one base index system, that is why 1111. Now setting all of the elements of the DP to be -1. -1 would indicate that we have not calculated the result of this state yet. What happens when you apply recursive approach is that same state may be required to be calculated more than once. For example, this state depends upon the result of this, so this would make a recursive call to this cell, right? So you need to calculate the result of 33. Now this cell again depends the result of this, so this would also make a recursive call to 33. So you see, a single state is being called multiple times. So in DP, what we do, we initialize all of the state to be -1. So DP of xy would store the state of DP of xy would store the result of that state. It would save whether we have been to this state or not. So what happens when this makes a recursive call to this and ask it to calculate what is the total number of ways you can reach from yourself to final destination. So it would calculate, and what we would do, we would store the result, so that next time when someone asks go and calculate the total number of ways from you to the final cell, so it would say I have already calculated the result, so I don't have to do again. I can simply take the result which I have saved in DP array and simply return that. So that is what happens here. So what you do, initialize DP with -1 indicates that this state, this xy state, is not being traversed yet. And then the fill function is being called. This last part is same as the iterative. Here we are simply printing. The all work is being done here. Fill is actually the recursive function which returns the total number of ways you can the total number of ways are there from cell xy to the final cell, right? So our answer would be fill of 11, because fill of 11 would return the total number of ways from 11 to nm. Now if you have watched the if you are following my graph theory series, you already know what this is. If you remember from when we apply DFS BFS on 2D grid, what we do, we write down a isValid function, and this is nothing but isValid function. What happens is that from, let me show you the recursive call, and then first, if DP of xy is not equals to -1, since we have initialized DP with -1, all cells of DP we have initialized with -1, so -1 indicates that this state has not calculated its result yet. That means we are visiting this cell first time. If it is equals to -1, that means we are visiting this cell first time, so we need to calculate. If DP of xy is not equals to -1, that means we have been to this cell and we have already calculated the result. If we have already calculated the result, then we have saved the result in DP of xy. That is why if DP of xy is not equals to -1, we will simply return the stored result. Otherwise, if DP of xy is equals to -1, that means we are visiting this cell first time. That means we have to calculate the result. And how you are going to calculate the result? Since we are working with recursive approach, of course, the total number of ways you can reach from here to final is the sum of total number of ways you can reach final from here plus from here. So that is the exact thing we are going to do. So total number of ways you can reach from xy to final is sum of total number of ways you can reach from x plus 1 y and x comma y plus 1. So that is why we would make two recursive call to these two cells. And take a look, we are storing the result in DP array, so that initially it was -1, but now it is storing the result, so that next time when someone calls fill xy again, we would see whether we have calculated the result or not. Since we have the next time it would be called, the DP of xy would not be -1, and then we can directly return it. And that is what is happening here. So now you know what is happening here, how the recursive calls are being made. These two things that you see in DP, these are called transitions. So in this problem there are only two transitions possible. In fact, there are exact two transitions from this state xy. Why I'm calling this state again and again, because these two things you see uniquely identify on which point you are. So in cell, row and column number can uniquely identify on which point you are, and these parameter of dp function are called function what we call state variables, and these uniquely identify the state on which you are. So from this state, suppose this was xy, there are two transitions possible, right and down, and the transitions that are possible make your recursive calls. And since there are only two transitions, that is why we would make two recursive calls, to x plus 1 y and x y plus 1. After all of the transitions have completed, we would store the result in dp of xy and finally return that. Now this, it is possible then that when you are making transition, suppose you are here and you make two recursive calls to right and down, but you can see down there is nothing. So when you go outside the 2D grid, whenever you try to go outside the 2D grid, we need to return 0, because there is no way you can go outside the 2D grid, you are not allowed to, and that is why we would return 0. If x is greater than n, that means it goes outside the row, or x is smaller than 1, that means it goes 0 or less than that. So we would return 0. Similarly for this, and this you must already know from graph theory. So if we are going to a cell which is not present, which is outside the grid, we would return 0, because that is invalid state, and that we would return 0. Otherwise, if x is equals to n and y is equals to m, this is the base case of the recursive call. So if you reach your final destination finally, from there we would return 1. So how many ways are there from nm to reach nm? Of course the result is 1, because if x is equals to n and y is equals to m, that means you are asking how many ways are there to reach final destination from final destination. So the answer is 1, and that is why when x is equals to 1 and y is equals to m, we would return 1. But before that, of course, we would store this into the dp array, even though at this point in the base case it is not necessary, but I've said it for no reason, I think. So let's run this. I hope you have understood it. If you are not able to understand this, this may be because you may be having difficulties understanding the recursive calls. So for that, I would advise you to go and study recursion, because recursion helps in many ways. Because let me give you a count how many ways recursion helps you. Recursion helps you in DFS or BFS on 2D grid. Recursion helps you in centroid decomposition. Recursion helps you in wavelet tree. Recursion helps you in segment tree. Recursion helps you in all kinds of DP recursive approach. So recursion helps you in many places. So don't take recursion lightly. I would highly advise you to study recursion in as good way as possible, because what am I doing? Because this will help you in many problems which you can solve in competitive programming. Without the help of recursion, you might feel difficulties. So as you can see, even the recursive approach is working fine. The result is exactly the same as this. So if you are having any difficulty with recursion, I would highly advise you to go and study recursion first and then continue. Why I'm explaining the recursive as well as iterative approach? Because in most of the problems, when we would be taking on some difficult problems, like some problems from Codeforces rated 2000 or above, I'll be explaining the recursive approach, not the iterative one, because it's not like I cannot explain the iterative one, but recursive one, writing down the recursive approach is much easier than writing down the iterative one, even though the runtime of iterative is a bit faster than recursive. So iterative approach itself having certain positive points, so that I'll be leaving on to you, or if I'll be getting more requests, then I should be discussing iterative more than recursive, I'll be going for that as well. But my but my priorities would be on iterative approach, and I want you to be comfortable with iterative approach, because the problems like DGTP become too easy when you have iterative approach in mind. So this was all for this lecture. If you have any doubt or query, of course you can ask on the article that I've created for this course on CodeChef on discuss.codechef.com. so the link of that article I'll be posting in the description of this video, and also the lectures that I have told you in the beginning of this video, link of those lecture also I'll be putting in the description of this video. So thank you guys for watching. Until the next video drops, keep coding. Thank you.